Hello folks, again it's been a few days without a daily chatter, and that's because I really haven't had anything interesting enough to share with you. But today I have, so first let's talk a little bit about, well, to begin with, I'm gonna say you right now, I'm gonna do some talking first, and after I'm done talking I will show you some pretty interesting manual machining, manual turning work. So even if you don't like me talking, you can scroll at the end of the video and see some manual machining. So let's carry on with the talk. Anyway, so I have now all the crowbars done, every single one, 1008 of them. And I finished the last one yesterday, and they came out pretty nice. And there's two of these that have pretty nasty scratches on the stock. So we will have to see if they will clean up in the blasting. I don't think they will. And somebody was asking about using the coolant, which I was not supposed to do. And I called the customer, and he actually said that these have been machined with the coolant on before as well. They just have to be cleaned very well. So I guess what he actually meant is that these pieces do not are not allowed to have any oil on them. He was not saying that you must not use coolant when you machine these. So when they came out of the machine, I wiped every single one of them with a rag, and now you can see I still have to rearrange these in the pallet, and when I do that I will dump them in a bucket of water and some solvent. So that should be just fine. And well, what else? Some nasty things about 1M63 lathe. I put the pin back now, and the carriage is actually moving now, which is awesome. But I found some more problems with it. By taking a closer look at inside the carriage box, I can see that there's at least 2 bad bearings. So something pretty radical must have happened inside that box. So I'm not sure if it's gonna work in the condition that it is now, but I'm not sure either if I even want to try using it. So I think this will be another project for another time. At the moment I have too much work to fix it. So I will do it, but I just don't know when I have the time. It's pretty bad actually. I was pretty disappointed when I found that out. So let's get to something else. Well, this is the aftermath of the machining clips that you're gonna see at the end of this video. I made a pretty good amount of steel chips, and you can see for some reason even the steel chips, I mean the drilling chips, are all broken off very beautifully for some reason. Maybe you will find that out. And let me show you something more that I've been about to show you for a long time, but I haven't remembered. So this is the aluminum rim that I showed you a long time ago in one of the first daily chatters, and I have it repaired now. I put some pretty good weld beads on there, and actually what I did, I ground off all the crack so that there was like a 2 inch by ½ inch, a large hole in the rim. So I ground it all off, and then I just weld filled it back. And this is what it looks like on the other side. You pretty much cannot even see what's happened here, and that's pretty good. I never like to just weld over cracks. I have found it not to be a very good technique. So I always like to grind off the whole crack and build it back with 100% and actually a little bit more, because I didn't grind it off this side. So there's more material than there used to be. It's just that the metal isn't as strong as it used to be, of course. I like doing these kind of repairs. They save the customer a lot of money, and they're somehow fun to do. And the final thing to talk about is the late 1i611P variable frequency drive. So I think it was yesterday that I brought it to the electric repair shop in my town, which I have used before, and I really like what they do. And today I got a call from them, and they have looked at it, and they found some kind of device module. I can't recall what it was. That was shorter, completely shorter, and they didn't find out what it was caused by. They didn't find anything. They didn't find any chips, at least, or anything like that. But they said that sometimes they just fail without any good reason, and that's pretty weird to me. But they actually ordered a new part, and the part and the labor to fix it will cost me less than 200 euros, so I will get it fixed. It's a little bit more expensive than ordering a Chinese VFD, but I'm gonna go with the Danfoss and support the repair company. So it should be ready to be picked up next Wednesday, so we have to wait until that to see if it actually works. So I guess that's all for now, and let me give you a channel of the day right now, and after that I'm gonna show you some machining. Okay, a little intro to the machining clips. So this is what I'm making, or what I made. It's now finished. At least the turning and the machining work is now finished. So can you spot any similarities? So this is kind of a support head for a rock drilling machine for a friend of mine who does rock drilling. And this is a part that he has to replace pretty much once a year, because this part right here will get a rubber boot to it, like this, and the rubber boot is sitting against the rock, kind of in this way, and the drill rod is going through here, and of course drill the rock, and then right here I will weld a pipe which will attach to a vacuum cleaner kind of device, pulling out the cutting fluid and the dirt that comes from the drilling. And right here I will still have to drill 4 holes that will attach some wear pieces, kind of radial bearings for the drill rod. And all of this will be welded to a support kind of fixture. I have a better picture of it right here. So I have already made these plates, and I will weld them back together, and this is the original design, and this design right here is one of my own, and this design should be like 10 times better than the original. Because can you imagine, of course you have to fit the drill rod in here through one side and not always through here, so this has to be openable. You have to be able to open this, and well, you may or may not have noticed yourself, but this piece is actually not one but 2 pieces. It's split in middle, and there are 4 M12 hex cap screws holding it together. And this is so that you can remove this piece, and the whole half of this part will come loose, and then you can slide the drill rod in. And the support bearing will be in two parts. One of this will be on this side and one on this side. And can you imagine, the original one only had a hinge right here and kind of a very bad locking system with a butterfly type of knot, a single knot to hold it together. And of course, when you drill with it for a year, it just doesn't last. The friend said that he actually has to repair it like once a month, and it just becomes loose right away again. So this design should be way better. But this is kind of a prototype. I will make more of these if it turns out good. So we will see. Will be interesting to see how it works. And I think now I can show you the clips. And of course the reason for the chips breaking is that I started this by using two 100 by 50 or 4 by 2 inch pieces of flat steel stock, and I first drilled the hole pattern, threads on one side and clearance holes for the bolts on the other side, and then I bolted it together and milled all the sides flat, and of course also the split line right here is milled very flat and clean. And then I just set it on the forjaw on the TOS lathe and dialed it in a little bit and started turning. First I made this OD profile and then the bore which goes right through, and then I flipped it on the other side and did this side. And the last thing to do was to mill this hole right here for the vacuum cleaner pipe. And of course the reason for the chips breaking is that there's a split in the material every 180 degrees, and so no matter what kind of cutting data you use, it always breaks the chip, of course, because the material is broken in itself. So now a channel of the day, and then I will show you the clips. Okay, today's channel of the day is a Ukrainian guy. I guess his name is Ratko Maxim or something like that. I don't understand a single word that he's saying, but I guess machining is like football. It's a universal language. So this guy is an extremely skilled metal worker. He's running his own shop, and he only has manual machines, but he does some pretty impressive things with them. And he also does very nice video work. So for example, he's making shaft like this, and at the beginning of his video he always greets you with his name, and he has very good plans. He shows the plans first and then he shows you every single step that he does. He uses pretty primitive cutting tools, if you ask me. But the results are they just speak for themselves. So he shows turning work first, and then on another lathe. By the way, this lathe is exactly the same as my 1i 611P, so this is the same lathe as the one that he's using now. And actually, this lathe right here that I used previously is exactly the same lathe as this one right here. So this is 1K62. My lathe is 1K625, so it has a little bit more swing over bed, but other than that it's exactly the same lathe. So turning work, and then milling the QA. He just makes it look easy. And then he uses his shaper to form an internal keyway, which is pretty impressive as well. You don't see much shaper work, but this guy does a lot of it. And here you can see some action. And I think looks like he's not heat treating it this time, but he also does all the heat treatings himself. He has a small oven. And then he has a shaft grinder, cylindrical grinder, that he uses to finish the shaft. And this is just an example of the kind of work he does. He does all kind of things with metal. So please check out this guy's channel. He also has at least one video in which he speaks English, and his English is much better than mine. You can try to search for it in his videos. I cannot recall what he makes, but I will give you the link to this guy's channel and also to the English video in the description of this video. So please check this guy out, you will love his videos. Okay, thanks for watching, and now to machining this part on the manual TOS lathe. Finally.